Hello everyone, I'm Shahrzad Mirsoltani, astronomy educator from Iran, and also I'm the collaborator of the NUCLIO, Austrian Space Forum, and the Explore project. And today I'm going to talk with you about the Explore project, bringing Mars analog astronaut missions to the students worldwide. When we talk about the red planets, when we talk about the Mars, we remember a lot of stories from the ancient times, from the times that people were just observing this planet as a tiny red dot in the night sky until the time that we started to explore this planet with our spacecraft, with our rovers, until now that we have not only the dream of exploring this planet ourselves with our astronauts, but also we have the goal for it. In order to achieve these goals these days around the globe in different space agencies, institutes, we have simulations for the future humans missions to the Mars or to the moon. We call these kind of missions actually analog astronaut missions. These missions happens on the Earth. They're not in space. They're not on the moon. They're not on the Mars. Actually, we try to simulate the conditions that we will face in the environments, for example, of the Mars or of the moon on the Earth, and we try to make some kind of experiences for the astronauts, which we call them the analog astronauts, that they can gain knowledge, they can do different kind of experiments, they can do different kind of tasks, and in conclusion I can say these kind of missions will give us some kind of knowledge and experiences that help us for our future possible future mission. When we go to Mars, we may face challenges. We wanted to know what should we do. We want to test our actually robotic rovers or anything that are related to the humans exploration, whether it's the astronaut themselves or the technologies that we are going to use in the future exploration of the Mars planet or moon, let's say. And if you search on the internet about the analog missions, you will see that most of the missions are usually for the people from different background. I mean, people, adults from college, universities, or astronauts from the different space agencies or different institutes. But think for a minute that what if your students from any part of any place on this planet, they also have the chance to participate in a analog astronaut mission, and think that they also can gain this kind of knowledge, experiences, and they also have the opportunity to learn about the analog astronaut missions and the future humans' future missions to Mars. This is where I have to introduce the Explore project for you. This is a Erasmus project, and it's funded by the European Union, and also it's a project where we invite students from across the globe to participate in the project. That within this project they will have the opportunity to gain knowledge about different topics related to the this exploration, these future missions. Actually, this is an interdisciplinary project, so the students will work and will learn about different topics that is related to the future Mars missions. We have different kind of activities in the field of STEAM and also STEM area. We have hands-on science activities, and this project is not only inviting the students, but also it's inviting their teachers to bring the students to the project. And this is an amazing project, and it can give an amazing opportunity to all the students around the globe. How it's possible? I think you will have this question in your mind at the first glance. First of all, we have 5 partners from Europe, from different European countries, as you can see, like from France, Portugal, Greece, and Austria. Austrian Space Forum is the coordinator of the project with a background in the field of analog astronaut missions. And all these partners together, they are covering different parts of the project, and together they are making this extraordinary project happen. And we have 2 different kinds of toolkits that with the help of these toolkits we can make this great experience for all the students happens. First of all, we have the physical toolkits, which is basically for the students and the schools that are partners of the project. I mean, the physical toolkits goes to the schools in Greece, Portugal, and Austria. And also, on the other hand, we have virtual toolkits that there's no borders for that, and any student, any teacher, any organization from from any part of the world that are interested in this kind of projects, they can participate in the project. And beside this physical toolkit and virtual toolkit, we are having two major analog missions. That the first one happened in June 2025 in the habitat that was built for the Explore mission in Alqueva Observatory in the Montserrat, and it was an amazing analog astronaut missions. And on the analog astronauts missions were the students, and the persons who were leading this project beside the Explore project teams was the teachers of these students, because today I'm going to focus on the physical toolkit, and I wanted to invite the people from other countries. I'm not going to focus on the mission and physical toolkit, but instead we are going to explore the virtual toolkit together to see how is that possible, how remotely and from different parts of the world the teachers and the school and students can participate in the project. As you can see here, we have different kind of toolkits, and all of them are focusing on one subject or two subjects, or more than two subjects, because as I mentioned, they are interdisciplinary activities, and they can be implemented in different classes, like science classes, if you're a physics teacher, if you're a chemistry teacher, if you are working on robotics, if you're working on programming, you can work with the students. And me as an astronomy educator, and with my project, Kargahe Setare Project, which is an international initiative, online initiative, I can say, in Iran, and also for the migrated Iranian students across the globe. Now we have this project for more than 50 countries across the globe. The previous year, in 2025, for the previous mission, we had the opportunity to participate in the project with the virtual toolkit. Imagine that from all provinces from Iran, and also in near 50 countries across the globe, more than 200 Iranian students have the chance to participate in the Explore project with the virtual toolkit. And as you can see here, there is no limit, there is no special things, there is no challenge. This is my personal experience. Beside that, I'm working with the team. I had the experience with my students, and with the most simple things that you can find at home, you can participate in the project, and your students can get knowledge about this virtual toolkit. You can see the complete list of the virtual toolkits in our website. Because of the time limits, I cannot explore all of them, but I'm going to show you how are we going through this journey with the students. For example, we have an activity in our virtual toolkit, exploring Mars with Scratch. I'm sure that you know how it's important for your students to know how to program, and Scratch is one of the simplest languages that most of the students across the globe they can work with that. So we have an activity regarding the programming, and it's really amazing. Imagine that your students have the chance to use a real surface photo of the Mars and in the background, and then you can use a rover there, and this rover will start collecting the sample, just like a real rover. Remember the Curiosity rover or Perseverance rover, which are doing the sampling on the Mars right now. Your student using this toolkit and using the Scratch and programming, they can have the similar experience too. Or imagine that we train our astronaut. We want to see that how they can, for example, react to the things, how we can calculate and measure their activities. So Train Like an Astronaut is an activity where they can actually do different kind of tasks. Also, they are really fun, and the students enjoy it. And also they can see how they can perform, they can calculate it. And this activity can be done in different kind of classes. Or another activity we have is learning sampling. it's amazing. The students go inside the nature. They will collect different kind of rocks, soils, metals, sands, and they will use the science of sampling in order to sort them, categorize them, just like a real mission, just like the things that our real honorary astronauts were doing the same activity in the habitat. Another one is related to the robotics. It's amazing. They can build mechanic hand, or they can build robotic arm, and they can gain experience with the very simple tools. You don't need to buy anything. They don't need to go to the stores and provide a lot of things. With the simplest things that are available, they can see how does a robotic arm work, how do we use them in Mars exploration, how a mechanic hand help us. Or another one, if your students are interested in chemistry, or are you a chemistry teacher or a physics teacher, you can make Martian soil in your classes, just with the soil, with the iron filling and the little water. You can see that we can simulate a Martian soil. We can build this red Martian soil in our classes, and your students can observe them. They can make a report, and they can create their Martian soil. It's another of our virtual toolkit. And also we know that with nothing having the ability to work in a team together, we are not able to go to Mars. We are not able to discover this red planet. Team power is an amazing activity that helps the students to have this, to improve the skills of having teamwork together, and with building and solving different kind of challenges together and having discussion. They will gain these skills, and this one will also help to them. And one of my favorite toolkits is Off to Mars. It's a little bit advanced, but with this toolkit, during the physics classes, mathematics classes, you can teach different topics. Kepler's laws of planetary motion, how do we launch a rocket to the Mars, why we don't send the rocket from Earth directly to Mars, how we can arrive there. And so your students, using this toolkit, they will gain knowledge about different topics. So all of them are online. They are available to all the teachers, and I had hundreds of videos and pictures. These are the outcomes of our classes. You can see my students with the mechanic hand. They built the robotic arm. They simulated the Martian soil. They started doing sampling and organizing and categorizing their samples. So the result was amazing. Not only they gained knowledge about the analog missions and the future the humans mission to the Mars, but also they gained knowledge about different topics such as chemistry, physics, mathematics, and also the skills that are related to social activity. So you're welcome for the next year of the project. In 2026, the project will continue, and there is no limit. If you're interested in the project, and if you're also a secondary school teacher, or if you have any organization in any part of the world, you're welcome for the next year. We will have more resources. We will have teacher trainings for also international teachers. We will also have more toolkits, and these toolkits and resources are available to everyone. And also I can say that even you can participate in the real analog mission in 2026 remotely. And just all the things that you have to do is you can contact us through our website, our Facebook. Here you can see the email of the project too, and you're welcome. And also you can see the virtual toolkit and other information about the project in the website. And I myself, I'm the the person who is responsible for the international collaboration. So if you have any suggestion, if you have any question, or if you are interested in the project, don't worry. We will train the teachers. We will give you the virtual toolkits. We will give you the resources. All you need to do is to contact us, and we will be happy to inspire more students across the globe. And who knows, maybe one day in the future, one of your students becomes one of the real astronauts who are going to explore the red planet for the first time in the history. So thanks for your attention.